Hi, welcome. Today we're going to be going over section 4.2, multiplying and dividing rational expressions. In this video, we'll discuss the definitions and kind of the basic process of how to multiply and divide rational expressions. Let's recall multiplying fractions. So, if I have 2/3 times 12/5, what do? Divide first. If you can, anywhere you can, divide first. So I look at my pieces. I have a 12, which could be divided by 3. If I divide first, 12 divided by 3 is 4. Are there any other pieces that can be divided? No. So that's it. 4 times 2 is 8, and 5 times 1 is 5. So that is 8/5. Now, how do you divide fractions? You multiply by the reciprocal. So this little rule is called keep, change, flip. You keep the first fraction, you change that sign to multiply, and then you flip the second fraction or take the reciprocal. So dividing fractions, keep, change, flip, aka multiply by the reciprocal. Okay, and then I go back to divide first. Notice 9 divided by 3 is 3, and nothing else can be simplified, so that's it. Then I multiply what's in the numerator. 2 times 3 is 6, and then 7 times 1 is 7. So this would be 6/7. One very important idea is you cannot divide unless you're multiplying. So, for example, if I had 2 over 2x plus 1, I would be very tempted to divide those 2's. You cannot because you're adding that 1. Now, if I had 2 over 2 parentheses x plus 1, I'm multiplying 2 times x plus 1. In this case, you can divide the 2's to 1. Okay, so be very careful. You cannot divide unless you're multiplying. Multiply, divide, right? Add, subtract, multiply, divide, separate planets. Make sure you know those rules. So doing this right here is a no-no. Doing this here and getting 1, that's perfectly fine. All right, let's check out the example. We notice that 5y plus 15 divided by 2y times 6 over y squared minus 2y minus 15 is the problem they give us. And we want to factor. First, we want to take out the GCF. What can I take out? So notice in the numerator of the first piece, we took out a 5 as the GCF. That means we divide both terms by 5, and we get 5y plus 3. In the denominator, 2y, there's nothing to factor. The next numerator, 6, nothing to factor. And then in the denominator, y squared minus 2y minus 15 does not have a GCF, but we know that it has 3 terms, a trinomial, and we can factor it into 2 binomials using our template pattern. So 2 numbers that multiply to give you -15 and add to give you -2. We notice the sign is negative, so we need one of each to multiply to get a negative, and then the bigger pile is negatives, so the -5 plus 3 will give you a -2 when adding. All right, then divide. Notice all these pieces are in parentheses, so they're being multiplied, which means we can divide. So you can divide the y plus 3 because that's one term being multiplied by all the other terms. And we know that 6 divided by 2 is 3, so we can also divide there. Notice every piece is multiplied. That's why we can divide. Then they ask us to state the restricted values. So you look at the denominator, and remember the denominator cannot be 0. When I look at the factored form, I can clearly see what values can I plug in to make the denominator 0 and say, oh, we cannot have those values. Okay, in the first piece, y equals 0 would be the restricted value. And then 5 would be for the second piece, and then -3 in the third piece. So you see that the restricted values are those 3 values that make the denominator 0, and we do not want to divide by 0. That's the basic idea of multiplying and dividing rational expressions. Good luck with the problems. See you next time.